I am Pooja LR. I am studying first year MSc Chemistry in JSS College, Mysore. Today I am explain about UV visible spectroscopy. Meaning of spectroscopy: it is the branch of science that deals with the study of interaction of matter with light, or it is the branch of science that deals with the study of interaction of electromagnetic radiation with matter. The electromagnetic radiation consisting of discrete package of energy which are called photons. Photon consisting of an oscillating electric field and magnetic field which are perpendicular to each other. Electromagnetic radiation can interaction with matter in various ways. Each interaction gives us insight about certain properties of matter, and use of electromagnetic radiation of different information about the matter under study. There are various forms of electromagnetic radiation, example radio waves, gamma rays, x-rays, UV, visible rays. The arrangement of different types of electromagnetic radiation in increasing order of their frequency or decreasing order of their wavelength is known as electromagnetic spectrum. The highest wavelength is radio waves, lowest wavelength is gamma rays, and lowest frequency is radio waves, highest frequency is gamma rays. The principles of spectroscopy. The principle is based on the measurement of sample containing atoms or a molecule. Spectrum is a graph of intensity of absorbed or emitted radiation by sample versus frequency or wavelength. Spectrophotometer is an instrument designed to measure the spectrum of a compound. Its main is absorption spectroscopy. It is an analytical technique in which concern with the measurement of absorption of electromagnetic radiation. For example, UV range is 185 to 400 nanometer, visible range is 400 to 800 nanometer. Another is emission spectroscopy. Emission spectroscopy is also known as analytical technique in which emission of a particle or a radiation is dispersed according to the some property of a emission, and the amount of dispersion is measured. For example, mass spectroscopy. Main law is Beer-Lambert's law. It states that when a beam of monochromatic radiation is passed through a solution on a absorbing substance, the rate of decreasing the intensity of radiation with thickness of absorbing solution is proportional to the intensity of a radiation as well as follows the concentration of a solution. Then, for example, when we take a small amount of sample, it passes monochromatic radiation is passed through a solution, then decreasing the intensity of radiation with thickness of the absorbing solution is proportional to the intensity of incident radiation. Equation for Beer-Lambert's law is A is equal to epsilon Cl. A means sample's absorbance, epsilon is molar absorptivity, C is concentration of a solute, L is path length of a sample. The main topic is UV visible spectroscopy. It deals with the study of electronic transition of a molecule as they absorb light in UV is 190 to 400 nanometer, and visible region is 400 to 800 nanometer of the electromagnetic spectrum. It is very useful to measure the number of conjugated double bonds and also aromatic conjugation within various molecules. For UV and visible spectrum, electronic excitation occur in range 200 to 800 nanometer and involves the promotion of electrons to higher energy molecular orbital. There are possible electronic transitions: sigma to sigma star transition, pi to pi star transition, n to sigma star transition, N to pi star transition. First, we know about the sigma to sigma star transition. It is a high energy process since bond is generally very strong. The organic compounds in which all valence shell electrons are involved in formation of sigma bonds do not show absorption in the normal UV region. For saturated hydrocarbons like methane, propane, absorption occur near 150 nanometer or higher energy. We take higher energy. Next, pi to pi star transition. These type of transitions occur in unsaturated center of a molecule. The compound containing double bond or triple bond also in aromatics. For example, alkenes, alkynes, carbonyl compounds, cyanides, azo compounds, etc. shows pi to pi star transitions. Next, n to sigma star transition. These type of transitions takes place in unsaturated compounds containing one heteroatom with unshared pair of electrons. For examples, some compounds undergoing these type of transitions are saturated halides, alcohols, ethers, aldehydes, ketones, amines, etc. The next one is N to pi star transition. This type of transition, an electron of unshared electron pair in heteroatom get excited to N to pi star antibonding orbitals. These type of transitions requires least amount of energy out of all the transitions. And next, applications of UV visible spectroscopy. First, quantitative and qualitative analysis. Quantitative, it is used to determine the concentration of a substance in a solution and also identify the presence of a specific compound. Next, monitoring the chemical kinetics. UV spectroscopy can track the progress of the chemical reaction by monitoring changes in absorbance over a time. Next one, determining the purity. UV visible spectroscope can be used to detect the quantified impurities in a sample and also used in pharmaceutical analysis. It is used for drug discovery and quantifying impurities in drug ingredients in so many. And next one is environmental science. UV visible spectroscopy is used to analyze the pollutants in a water and air and also used in forensic science. UV visible spectroscopy can used to analyze the dyes and pigments and also used in food and beverage analysis. Thank you.